Alright, a 0.85 kilogram mass is attached to one end of a horizontal spring while the other end is fixed. So this figure 1 shows the graph of displacement against time of the system which freely oscillates in a simple harmonic motion. Okay, so simple harmonic motion. So determine the equation of displacement as a function of time. So we want to find what equation? Displacement versus time equation. Okay, so I want to write that down. Okay, 1 second. It's not. Okay, so we want to find the displacement against time. So this is displacement versus time equation. So we want to find this equation. So remember the displacement equation. Our displacement equation. Look back to our summary. See, displacement equation is what again? A sine omega t. Yeah, A sine omega t. So it's a sine graph. So back to our question. So this is a sine graph, correct or not? So our general formula just now is A sine omega t. Write that down. Okay. So question A. Okay. Y equal to A sine omega t. That's our general formula. Okay. And so what is the amplitude? So our amplitude is, this one, this value, right? This is our A. Okay. This negative A. Okay. And then this is the period. This is the period. Be careful with the unit. Be careful with the unit. This second, but this is centimeter. We need to change to meter. So be careful with all these unit. Anyway, you can actually still maintain as centimeter. Let me tell you why. You can still maintain as centimeter, but you must pay attention to the unit. Yeah, unit. So you can still make it as centimeter. Okay. Let me show you how. So this is amplitude is 1.8 centimeter. Yeah. Omega. Okay. What is omega value? We need to find what is the omega value. Yeah. So. Okay. So what is the omega value? Let me calculate. What is the omega value? Omega is 2 pi over period, correct or not? So what is the period here? 0.2 second. So put in the value period. So 0.2. Okay, second. So what do you get? And now you have 0.2. This one go one side. This one go one side. So it's 20 divided by 2 is 10 pi, right? 10 pi. So this is radian per second. Radian per second. Actually, radian you no need to write also. You can just write as per second. Yeah, because radian is not a unit. You can write as per second. Okay, so that's why here we have 10 pi. So that's the answer. Okay, but not complete yet. You must write the unit. You must write the unit. Okay, so just now here it shows that this is centimeter, isn't it? Amplitude is centimeter, right? The amplitude is centimeter, so the displacement also centimeter. Okay, so that means if this is if this amplitude is in centimeter, that means this displacement also in centimeter. Understand? And then here it shows that second, time is in second, so that means this period is also in second lah. Okay, this period is in second. This time is in second, so I can say this time is in second. Okay, so you must write the unit. You must write the unit where you just write the equation alone not enough. Yeah, you won't get full marks. You must write the unit also where y in centimeter, because the unit is centimeter given. Okay, and the value here you write also centimeter. Amplitude is centimeter. So when amplitude is centimeter, displacement also centimeter. Okay, so you must write where y in centimeter, and then comma t in second. Okay, that's how you write it. You must write the unit. Y in centimeter, T in second. Now B, what is the velocity and acceleration of the oscillation at any time? Oh, that means determine the equation of displacement and time. Determine the velocity and acceleration at any time. That means we need to find equation also of velocity and acceleration versus displacement versus time. So now the next task is find the velocity time equation and also acceleration time equation. Velocity time and acceleration time equation. So we have two tasks here. Velocity time, acceleration time. Okay. So right now, how going to do this? Velocity time, acceleration time. Very simple. Just use the general formula again. You know, what we have learned. Velocity time is, you know, a omega cos omega t. Acceleration time is negative a omega square sine omega t. Write that down. Okay. So B. So okay. So we just now we already got displacement time. Now we want to find velocity time and acceleration time. So what's the equation? What's the equation? So velocity time is, you know, velocity equal to maximum velocity is a omega, isn't it? Maximum velocity a omega, and then it's a cosine graph, cosine equation, cosine omega t. Whereas the acceleration is negative sine graph, and then the maximum acceleration is a omega square. So it is a negative sine graph. So negative a omega square sine omega t. This equation actually we have learned already. Just this one. This one, you see, velocity is a omega, acceleration is a omega square. Okay, velocity is cos. Yeah, velocity is cos. Acceleration is negative sine. Again, displacement is amplitude, and it's a sine equation, sine. And then velocity is a omega, cos equation. And then acceleration is a omega square, negative sine graph. Okay. So that's how we get it. Get all the equation here. A sine, a omega cos, negative a omega square sine. Okay. So okay, done. Now we substitute the amplitude. Yeah. What's the amplitude? 1.8 cm. And then omega value. And then, you know, omega also we got it already, 10 pi. So we can put in the value. Yeah. So you see, exam question, not the derivation lah. Yeah. It's more straightforward. Just use the equation only. So you don't have to be scared of this chapter. So, but first of all, we need to find a omega. What's the value? Okay, and in fact, a omega is the V maximum, right? V maximum is a omega, and then acceleration maximum is a omega square. Okay, so put in the value. Just now, a amplitude we got 1.8 centimeter, right? This 1.8 centimeter. Multiply the omega. Omega is 10 pi. 10 pi. So what do we get? Let's calculate. 1.8 times 10 pi. Somebody, you should help me, yeah? You should help me.
18 pi.
Huh? So, oh, yeah. Thank you. So it is 18 pi. And then the unit is what? Centimeter per second. We are not using meter, we are using centimeter based on the graph. Graph is using centimeter, so we must follow. We must follow centimeter per second. And then acceleration must be centimeter per second square. Okay, so let's continue. So let's find out this also. Acceleration maximum. It is 1.8 centimeter multiplied by this 10 pi. You have square some more, yeah? You have square some more. Okay, you have square some more, so it becomes what? It becomes 100 times 1.8, so it's 180 pi square, isn't it? 100, yeah, 10 square is 100, so you 180 and then pi square, and then so here you get what? here you get, you know, centimeter per second square. Okay, that's the acceleration. Normally it's meter per second square, but this one is centimeter, so you use centimeter per second square. Okay, you got the value already. Can substitute here. Yeah, can substitute here. So what do we get? So just now velocity is 18 pi cosine omega is 10 pi. Okay, and then you must write where the unit where velocity in centimeter per second. Understand? Centimeter per second. Time in second based on the graph. Okay, based on the unit given in the graph. Okay. So you must write the unit, you know. Yeah, just equation, you won't get full mark. You must write the unit. And then this one acceleration also must write there. Because if you don't write the unit, it is assumed velocity as meter per second, not centimeter per second. It is assumed as meter per second. So we don't know what unit is this. You must write out the unit so that we know what unit is this. So where acceleration in centimeter per second square. Okay, and then t in second. Okay, so that's it. That's it. Let me write a line to cross. What is this? Okay, understand? Understood? Class, understood? Boleh buat? Boleh lah kan? Terlalu boring kan? Sebab faham sudah kan? Okay, bagus. So itulah. Wait. Did I haven't write. Why nobody tell me? I haven't write the value here. Okay. So you must write the value also, yeah. So acceleration is what? Acceleration is negative. Just now 8 omega square already calculated. So 18 pi. 180 pi square. Okay, that's it. And then sine. What is omega? Omega is 10 pi. T. That's it. Okay, that's the equation for acceleration. Acceleration time equation, velocity time equation. So next time, if I give you a time, let's say time equal to 2 seconds, you can calculate the velocity at that time. You can also calculate. Hold on a second. Somebody calling. Okay. Okay, it's recording. So now, okay, now I want to find maximum speed. Maximum speed and magnitude of acceleration of the oscillation. We got it right. Maximum speed and magnitude of acceleration of the. That means the maximum acceleration also, I think. Yeah. Yeah, because acceleration changes all the time. What? Acceleration changes with time. What? Yeah, you give me the time, I can find acceleration. So acceleration always changes with time. So what he wants here is the maximum speed and maximum acceleration lah. Maximum speed, maximum acceleration. So he asks you for Vmax and Amax. We got it right. We got it. That is the here. This one lah. This one lah. So this is the answer for C lah. Yeah. For question C. Question C. So we already asked question C. We already got the Vmax and Amax. You also can calculate out the value lah. Yeah, multiply by pi. Pi is what? 3.142. You substitute the 3.142. You can get the value. Okay, or Vmax and Amax. So remember. If y max is amplitude. Okay, remember this. Y max is amplitude, V max is a omega, A max is a omega square. Very simple to remember. No omega, got omega. This one got omega square. Okay. Kalau ini unit centimeter. Ini centimeter per second. Ini centimeter per second square. Okay, next. Total energy of the system. So total energy, what's the formula again? Half m omega square, a square, amplitude square. Look at the formula again. Summary. Total energy formula. Total energy formula is always constant all the time. Yeah, is actually is this one is actually is either K max or U max, isn't it? Because when K max, the potential energy is 0. When U max, the kinetic energy is 0, isn't it? This value is actually the value of maximum kinetic or maximum elastic potential energy in the spring. When K is maximum, potential energy is 0. When U is maximum, K is 0. Yeah, the other way around. So total energy formula is half m omega square A square. This formula, okay, it always constant all the time because why? No energy loss due to friction. The surface is smooth. Okay, so total energy formula. Give me the total energy formula. Yeah, come on, you need to speak out, you know. Speak out.
Kinetic energy plus potential energy.
Half, I mean straight away half m.
Half m omega square A square.
Half m omega square A square. You will thank me for that. Yeah. In the exam suddenly ask for about total energy. Suddenly you remember that day I did respond to Mr. Peck, say that total energy is half m omega square A square. I helped myself that day. Okay, so that's the reason. So okay, half m omega square A amplitude square. Hopefully you remember the formula. Okay, so the mass is you see that this is the mass. Given the mass over here, the mass is over here. So omega you already find 10 pi, and the amplitude is 1.8. Anyway, this is centimeter. Be careful. This one you need to change the centimeter to meter because our energy is in joule. Joule must be in, you know, all the SI unit, kilogram, and then meter, and then second. Yeah. Must be in meter, SI unit. Understand? Can or not? Boleh tak? Can everyone remember this? Can you make a promise to me? Change everything to SI unit. Okay. So half mass. What is the mass? 0.85. Omega is unit per second. It's not related to centimeter. Don't worry. So this one don't need to change. Just 10 pi. Yeah. Second per second is already in SI unit. Yeah, SI unit. So just put 10 pi there. 10 pi and then square. And then amplitude. Amplitude is the one need to change to meter. Yeah, you need to change this to meter. So which is change it to meter. So I get what? Class, can you tell me? 1.8 change to 1.8 cm.
0.018.
Good.
0.018.
So I purposely put red color because, you know, SI unit is very important because this is energy is joule. Understand? Okay, then calculate for me the answer. 0.85 multiply 10 pi square multiply 0.018 and then divide by 2. 7.55 joule. Okay, so that's it. That's it. Okay. So that's the answer. Okay, everyone. Enjoy the lesson.
Sir,
0.018.
I think the amplitude needs to be square.
Ah.
Needs to be square.
Good. That's observant. That means you pay attention. Yeah, pay attention. How about the others? Are you paying attention also? Okay, that's good. Yeah, I need such a response. Yeah, so square multiply 10 pi square, and then some more what? Some more multiply 0.85 divided by 2. Okay. So the answer is so it's sometimes good to make a mistake here and there, and then I can catch whether you paying attention or not. Okay, so 0.136 joule, but I really make a mistake just now. So be careful with the square. Yeah, be careful with the square. I also make mistake. So be careful with the square. Okay, 0.136. Sometimes you answer the question too fast, like in the exam, and you might forget all the square, yeah, all this small stuff actually is the big stuff. Okay, you get a different answer. So correct, Okay, good.
Yeah, sir.
So